Afternoon, everyone. Thanks for your time to come and see us. So I'll just explain first about the partnership with ExxonMobil and Ampol and how that came about. So we made an alliance partnership about 5 years ago. What it really brings for our business, along with ExxonMobil, is their technology and global R&D and support. That's through our Australian arm in Ampol, with our people on the ground, fantastic network and ability to deliver things where it needs to go right across the country. So it's been a busy 5 years getting us started together, but we're certainly working well. We're about 75% of our mining products are all blended in Australia. So we have a production plant in Lytton in Queensland, where a lot of our products are made. And the benefits of that alliance partnership between Exxon's R&D and Ampol's ability to supply and manage the customers is really the foundation of the whole agreement. With me today we've got Abe Mitchell from the US, who's come out. He's a field engineer from Western United States with a vast amount of experience. We've been having lots of conversations here at the show today. And he also working on a lot of optimisation for customers and efficiency and how they use their products, and in particular with hydraulic oils, which is a real specialist area of yours, I know from the past. So thanks to Abe. Welcome joining him along to the event, and I'll ask you a few questions as we move into the interview process. So I guess first off the cab of the rank is with hydraulic oils, what's the performance benefits and why is it an important product for our mining customers in Australia?
Yeah, thank you, Sean, for inviting me here. It's great to be here. And thank you all for attending. For hydraulic systems, I think they are the heart of the mining industry. Without hydraulic power, we don't dig, we don't load, we don't haul, we don't dump, we don't do any of that stuff. And so in this today's globally competitive business world, mining operators are being driven more and more to get the maximum value out of that equipment. And so every little tiny improvement in efficiency and productivity matters. Could mean the difference between being successful and losing money. And so furthermore, with environmental concerns that are pressing on all of us, we have more pressure to come up with sustainable and energy efficient solutions. And so what that drives is in the design of these hydraulic systems, you end up with lighter, smaller, and higher pressure systems. And so in designing oils, coming up with a higher technology hydraulic fluid that will contribute to the success of operating these higher pressure, tight tolerance, lighter systems is a critical piece to achieving that productivity.
Can you also explain some common issues that customers find with hydraulic oils and what are generally the issues that they find?
Yeah, so about 90% of hydraulic component failures are actually caused by some sort of contamination, whether that be dirt ingression, hard particles that create abrasive wear, water that gets into the oil and is corrosive, or the degradation of the hydraulic oil. And so you have all these different factors that contribute to potential failures in the hydraulic system. On this slide here, you can see the little servo valve component there. These are really tiny little valves, but they are what control the entire machine. And as the oil breaks down, it can create varnish, which the oil is designed to hold that in solution, but eventually it will plate out in low pressure areas of the system, in cooler areas of the system. And the danger in this varnish is once it starts to plate out onto components, you can see by that amber color on the component there, it actually propagates throughout the rest of the system. And once that happens, it becomes very dangerous. And the result of varnish and sticky valves and other components is erratic operation, sluggish movements of the equipment. It can cause overheating, which will just contaminate the entire hydraulic system.
We've got another slide we'll just put up here if you want to work through some of the other contamination issues as well we see.
Yeah, and so like water ingression, dirt ingression, those can be solved with maintenance practices. You can add filtration to the oil. You can have good maintenance practices that will keep it clean in the first place. And so those can be prevented in that way. However, the varnish, which is what we really want to highlight today, requires a different solution and different prevention methods, different technology, and that comes through a balanced formulation in the oil. And in order to do that, we use some pretty cool technology. If you go to the next slide, in this balanced formulation, we have what we call keep clean technology. And we add this into our hydraulic formulations to prevent the formation of varnish altogether. It deals really well with high temperatures. It prevents the stuff that it's holding in solution from plating out. We do this 1,000-hour test called the mobile hydraulic fluid degradation test, which basically assesses the oil's ability to prevent varnish formation. It's a very rigorous test. As you can see here, several different oils are tested, and you can see from the visual there which oils plated out and created varnish on the component there. On the top right, you can see Mobile DT10 XL, which is our leading hydraulic oil, which is a huge varnish problem solver. The component looks brand new after 1,000 hours, and so that is evidence of the keep clean technology that is in the oil.
Yes, we also know from our own experience with a major iron ore miner in Western Australia where varnishing in the pumps was a major issue. We brought the technology from Mobile DTE 10XL to the customer, and you can see on the charts there it's just some filter patch testing for varnish, but the results were pretty immediate as soon as we changed the product over. It was running a zinc-free mineral-based oil in the past, so same viscosity but just different product in the machine. The top pictures there show those pumps when they came back to the warehouse or to the workshop for repair where it's got heavy varnishing on the equipment, and the second photo below is after 12,000 hours where there was virtually minimal build-up, and those results are actually backed up by the MPC results we see in the chart. So for the customer, a lot of it was around time efficiency, so keeping the equipment going, a significant saving in hydraulic pump failures, up over $250,000 a year. The product has the benefit of being able to run extended drain if the customer chooses to run it longer, and just the uptime and efficiency in the product has been significant, so a really good success with our experience using this in Australian conditions as well.
Yeah, it's great to see that the successes here in Australia. We've seen these similar types of results all over the world.
So on this one here, we're just looking at some of the, I guess that's more the efficiency of the machine. So as we use the hydraulic system and it keeps its power and its viscosity for longer. So obviously, Abe, you can talk through some of these charts here on the volumetric losses or the changes in how the hydraulic oil performs under load.
Yeah, so this is another piece of the technology that's designed into the oil. The best way to explain this, I want to tie it to sustainability, because we're all trying to figure out how to get to net zero. We're all trying to find more sustainable solutions. And what I find is that in the past, people didn't recognize lubricants as a part of that puzzle. But sustainability isn't a one solution solves the problem. Sustainability is going to come from lots of little pieces of the puzzle that all contribute to overall sustainability. And more, as I visit mines and talk through this, people are recognizing lubricants as a pretty significant piece of that puzzle. And so to tie this back to sustainability, let's talk about really quickly what a hydraulic motor does for sustainability. You have a rotating shaft input. That comes from a internal combustion engine, or it comes from an electric motor. Either you have to have electricity or you have to burn fuel to get that mechanical energy. Once that rotating shaft comes into the hydraulic motor, this motor converts that rotating mechanical energy into linear motion, and that's where your hydraulic power comes from. And so within this hydraulic pump, which you can see up there on the right, some thermal images of hydraulic pumps, there are losses. Hydraulic pumps typically operate at 80-90% efficiency. And so there are two different ways that we lose efficiency in a hydraulic pump: through volumetric losses and through mechanical losses. And if you look at this chart, I know it's a lot to digest right here, but through volumetric efficiency, as your viscosity or the thickness of the oil increases, your volumetric efficiency is at its maximum because you can push all of that fluid and convert it into work. However, as your viscosity increases or the thickness increases, you lose mechanical efficiency because it requires more power from that electricity, the electric motor or the diesel engine to convert that, because it just requires more power to push it. And so your mechanical efficiency is actually at its greatest when the fluid is thinner. And so the problem becomes, how do we design a hydraulic fluid that can grab both of those efficiencies and optimize them? And we do that through high viscosity index base oils. There's additives that we can add to the fluid to make it operate in the optimal zone regardless of what operating temperatures we're seeing. And so to do that, not all high viscosity index hydraulic oils are created equal. You have shear, those oils can still break down. And so creating an oil that's also shear stable gives you the best of both worlds, and you're able to operate in that optimal operating range for viscosity. And so ultimately, how does this manifest? If we can find that intersection point between the two efficiencies and minimize the losses of both volumetric and mechanical efficiency, essentially that translates into a couple things. Your cycle times increase. And so with a hydraulic shovel, for example, the movements are going to be more fluid, they're going to be more rapid, and you're going to get more work done in the same amount of time. Also, you're going to see a drop in temperature, which is what those thermal images are showing. With this DT10 XL product operating in the exact same conditions in the same hydraulic pump, you can see evidence of less heat loss because it's operating at lower temperatures. And so there's a lot of different ways that this energy efficiency manifests, but to tie it all back together, ultimately what you see is you're getting more work done for burning less fuel. That increases your productivity, you're hauling more ore in less amount of time, and that's where that's one way that this hydraulic technology really excels.
Yeah, it's a really good subject to cover, particularly in mining. We're always chasing the 1%ers, but I think you said in some of these scenarios here, there's up to about 6% in efficiency savings using these new hydraulic oils. So it makes a vast difference to the operational life of the equipment and also to the productivity and the tons out the door for the mine site.
Yeah, that's a great point. I mean, the way that this translates is actually pretty linear. If you're getting 6% efficiency gain in your fuel burn, let's just say you're burning 1 million liters of fuel per year, you can take 6% of 1 million right off the top, and that's what you're going to be saving in not only fuel costs, but also in carbon emissions from burning that amount of fuel. And so it's a pretty clean, direct calculation to say, hey, we're reducing our carbon footprint by X amount of CO2 metric tons based on the calculations that are out there.
Very good.
This is another technology that we see becoming more prevalent. It's pretty new for mobile equipment. It's common to see this in fixed assets like gearboxes and other things. But what this is sensor technology that can monitor the oil under live conditions. So typically what we see in mining is people are going to be pulling oil samples and they're going to send it off to the lab, and 5 days later they're going to get a result back and maybe create some work order to action a caution or an alert. Doing that method creates problems because there's delays in reaction time. You might miss a failure. You might change your oil too early, and so you're not getting the maximum benefit out of the life of that oil. And so this solution basically allows us to monitor that oil real time. So rather than waiting for that hydraulic system to go down for PM and pull a sample, you can monitor exactly what's going on in that oil live. You can monitor viscosity, temperature, you can monitor contamination levels. You can monitor wear metals or wear debris that's coming out, iron and other things. In engines, for example, you can catch events like coolant leaks or fuel dilution, and so it has all sorts of application in the mobile world. And it doesn't necessarily track exactly what you would see in a lab for events like that, but it alerts you that something is happening, and then you would go out and pull a sample immediately and send that to the lab, figure out what's alerting, what the problem is, and then apply your solution right away. And so this is something it's becoming more and more prevalent, and we're going to see this more commonly in mobile equipment moving forward.
Yeah, certainly agree. If we think about the last 30 years in oil analysis, it's sort of progressed slowly over time. I think originally just doing oil analysis was the new technology, but with AI and inline monitoring systems now, there's a real change coming in the next sort of 4 to 5 years that's really going to lock the two things in together. And I think the technology of the lubricants in conjunction with the condition monitoring applications that are available for the future is going to be really exciting for every industry, and in particular the mining industry. So that's our presentation for today. Obviously we've got the Ampol stand, so if anyone wanted to have some more discussions with us, we've got Abe for a little bit longer and our own technical team on stand over the next 2 days. So we look forward to you coming and see us. Thank you.
Thank you.